Cement production begins with carefully selected minerals from ancient geological deposits. Mark this sample for chemistry.
Layered limestone provides the calcium foundation required for dependable Portland cement.
That lighter seam is our target.
Geologists identify consistent limestone layers before heavy extraction work can begin.
Keep the cut above that clay seam.
Clay contributes silica and alumina needed for strength-forming chemical reactions.
Moisture looks right in this section.
Gypsum later regulates cement setting time during final grinding operations.
Clean crystals, minimal contamination in this pocket.
Corrective minerals balance iron, silica, and alumina within the raw blend.
Keep every source behind its marked divider.
Careful mapping keeps mineral quality stable across every extraction sequence.
The next cut begins beyond marker 12.
Dense limestone carries calcium carbonate essential for producing strong cement clinker. This fracture shows excellent consistency.
Clay's fine particles supply reactive silica, alumina, and trace minerals.
Bag the middle layer separately.
Layered shale adds controlled silica and alumina to cement chemistry. Clean split, send this for analysis. Natural gypsum provides sulfate that prevents cement from hardening too quickly. Label that one for purity testing.
Iron-bearing stone helps clinker form efficiently inside extremely hot rotary kilns.
This reading falls inside the blend target.
Moisture behavior reveals fractures that may influence crushing and blending consistency.
No major voids visible in that section.
Each geological layer contributes different elements to the cement raw mixture. The main limestone starts above this marker.
Veteran drilling crews prepare precise extraction points across the limestone bench.
Hold there, center the mast on marker 6.
Rotary drills open controlled holes while water captures airborne limestone dust.
Alignment steady, water flow holding.
Strict clearance procedures protect every worker before controlled rock fragmentation begins.
All personnel accounted for, secure the access road.
Fragmented limestone settles into manageable sizes for mechanical loading and transport.
Wait for full inspection before equipment enters. Experienced operators gather fractured limestone using powerful hydraulic excavators and loaders. Easy swing, truck is lined up.
Representative samples verify quarry quality before collected materials leave the source.
Sample logged, this load can move forward.
Freshly quarried limestone is sorted by size before transportation begins.
Slow the feed until that section clears.
Source inspectors remove contaminated fragments before materials enter the haul stream.
Reject that dark piece on the right.
Clay batches are separated by moisture and mineral composition at collection.
Use the center bay for this shipment.
Gypsum crystals are gathered carefully to preserve purity for later blending.
Separate anything carrying visible clay.
Corrective minerals are measured precisely before joining the primary raw materials. Stop there, that weight matches the target.
Wheel loaders transfer limestone into heavy trucks using controlled loading cycles.
Center that bucket over the rear section.
Even weight distribution protects truck stability across rough quarry haul roads.
Add one small bucket toward the front.
Covered trailers prevent moist clay from drying or contaminating during transit. Clean the seal before closing the cover.
Gypsum receives gentle handling because unwanted clay can affect cement setting.
Keep this container upright and covered.
Final dispatch checks confirm every load, route, and safety requirement. Lights are good, cover is secure.
Quarry trucks follow controlled routes toward the cement plant receiving area.
Loaded truck entering the East Hall route.
Watered haul roads reduce dust while experienced drivers maintain safe spacing.
Spacing is good through the lower curve.
Long conveyors can move limestone efficiently from nearby quarries to plants. Bearing temperature remains inside the normal range.
Gate personnel verify digital manifests before trucks enter the processing facility. Manifest matches, continue to the limestone receiving lane.
Staging lanes organize incoming materials and prevent congestion near receiving systems. Clay trailer, move ahead to lane 3.
Receiving crews direct each mineral toward its designated unloading station. Limestone to hopper 1. Clay remains in lane 3. Certified weighbridges record incoming mass for inventory and process control. Hold position until the weight stabilizes. Automated probes collect representative samples from every arriving limestone load. Cycle complete. Send the container to inspection.
Veteran inspectors check color, texture, moisture, and visible contamination immediately. Minor clay present, but the sample remains acceptable. Laboratory clearance releases accepted loads into the first processing stage. Results match the quarry profile. Release the load.
Position is good. Begin the controlled tip.
Accepted limestone enters enclosed hoppers where controlled feeding begins immediately.
Heavy apron feeders meter massive stone blocks toward primary crushing. Hold this rate until the hopper level drops.
Extraction systems capture dust before limestone reaches downstream processing equipment.
Pressure remains steady across every filter section.
Magnetic separators remove stray metal that could damage crushing machinery. Metal removed, feed stream remains clear. Clay preparation screens remove roots, oversized debris, and unwanted stones.
Approved clay is moving cleanly to the next stage.
Primary crushers reduce quarry stone into smaller, manageable fragments efficiently. Feed remains even. Motor load is stable.
Powerful impact hammers fracture limestone along natural planes and weaknesses. Fresh fractures look uniform across the discharge.
Veteran operators balance crusher speed, feed rate, and motor load.
Load is returning to the normal operating band.
Crushed limestone exits uniformly, ready for blending and storage operations. Tracking is centered, and material flow looks even. Rotary breakers loosen sticky clay before accurate proportioning and blending. Discharge is loose enough for controlled feeding.
Secondary crushing produces consistent particles for efficient raw material handling. Product size is holding inside the target range. Vibrating screens separate oversized fragments for another controlled crushing pass.
Oversize is returning normally through the closed circuit.
Corrective minerals receive separate crushing to preserve precise blending control.
Iron batch complete. Begin the approved cleanout cycle.
Belt scales continuously measure crushed limestone entering the pre-blending system.
Flow rate remains steady at the target output.
Chevron stacking spreads limestone variations across hundreds of thin, overlapping layers. Complete this layer before reversing the boom.
Bridge reclaimers recover multiple layers, creating a more uniform limestone feed. Maintain a steady cut across the full pile face. Calibrated feeders combine minerals according to constantly updated laboratory targets.
Increase clay slightly to match today's chemistry target.
The combined feed now carries every mineral required for clinker production. Seal that crossbelt sample for immediate verification. A sealed airlock introduces proportioned minerals into the vertical raw mill.
Feed seal is stable. Enable the grinding circuit.
Massive rollers grind mixed minerals into fine, chemically balanced raw meal.
Vibration is low and grinding pressure remains steady.
Raw mill stable. Dynamic separators return coarse particles while finished raw meal moves onward.
Fineness is back inside the approved range.
Recovered hot gases dry mineral moisture during the grinding process. Temperature is even across the entire duct surface.
Fabric filters recover valuable raw meal while cleaning process exhaust air. Pressure drop remains balanced across every compartment. Frequent sampling confirms raw meal chemistry before kiln processing begins.
Seal this composite for immediate chemical analysis.
Pneumatic lines fill homogenization silos with finely ground raw meal. Distributor is moving evenly across the silo top. Controlled air pulses blend silo layers into uniform kiln feed.
Uniformity is improving across the lower blending zones.
Homogenization target achieved. Precision dosing maintains steady raw meal flow into the preheater.
Actual flow now matches the kiln target exactly.
Cyclone stages heat descending raw meal using rising kiln exhaust.
Stage temperatures remain balanced throughout the tower.
Cyclones separate heated minerals from gas through powerful swirling motion.
Separation efficiency is holding above the required target. The calciner removes carbon dioxide before material enters the kiln.
Temperature and oxygen are returning to the target band.
Preheated material enters the rotating kiln for final mineral transformation. Inlet seal pressure remains steady during rotation. Kiln rotation continuously tumbles material through steadily increasing temperatures.
Material movement remains even across the kiln bed.
Minerals react and fuse into hard clinker nodules within seconds.
Nodule size looks uniform through the burning zone.
Infrared scanners protect kiln refractory by detecting unusual shell temperatures. Thermal profile is even across this entire section.
Glowing clinker leaves the kiln and enters rapid air cooling. Discharge is even across the cooler inlet.
Powerful fans cool clinker while moving grates control bed depth. Outlet temperature is dropping through the target range.
Recovered cooler air returns valuable heat to the combustion system. Recovered air temperature remains stable for the calciner. Clinker crushers reduce oversized nodules before storage and final grinding. Roll gap is producing the correct discharge size. Cooled clinker travels toward storage before final cement production begin.
Sample recorded. Route this lot to Silo 2.
Clinker is reclaimed evenly from storage to stabilize final grinding. Hold this gate position until the belt load settles.
Gypsum and limestone additives are metered beside the clinker stream.
Gypsum rate now matches the laboratory target.
Finish mills grind clinker and gypsum into extremely fine cement.
Power is stabilizing after that heavier clinker section.
High-efficiency separators return coarse particles for another controlled grinding cycle.
Fineness is entering the approved product range.
Aerated silos blend finished cement before quality approval and packaging. Silo 4 is filled and ready for quality hold.
Inspectors compare cement color and texture against approved reference samples. Color is consistent with today's approved reference.
Temperature and moisture checks protect cement flowability during storage operations.
Moisture is low and temperature remains safely controlled.
Online analyzers verify particle size distribution throughout final cement grinding.
Increase separator speed slightly to reduce the coarse tail.
Dust control inspections prevent product loss and maintain clean working conditions. All seals are clean and pressure remains normal.
Silo inspections confirm stable levels, aeration, pressure, and discharge flow.
Pressure response is normal across every aeration zone.
Enclosed conveyors move cement without introducing moisture, debris, or contamination.
Seal is dry, and bearing temperature remains normal.
Veteran technicians verify bulk cement samples before final production release.
Lot identification matches Silo 4 and today's shift.
Routine mill inspections identify wear before performance or quality declines. Bearing condition is stable and liners remain serviceable. Control room trends reveal small process changes before specifications are affected.
Temperature is rising slowly, so increase ventilation slightly.
Quality teams review every result before releasing cement for packaging. All reviewed results meet the current product specification. X-ray fluorescence confirms precise oxide chemistry within every cement batch. Pellet surface is clean and ready for analysis.
Blaine testing measures surface area and predicts cement hydration behavior.
Airflow time places this sample inside specification.
Laser analysis maps particle sizes that influence strength and workability.
Laboratory distribution agrees with the online process analyzer.
Setting time tests confirm cement remains workable before hardening properly begins.
Record this penetration for the initial set curve.
Mortar cubes demonstrate the compressive strength developed by finished cement.
Strength exceeds the required value for this test age.
Final blending systems stabilize cement properties before bags reach packaging lines.
Outlet flow is stable across the final blend.
Release valves direct approved cement toward dedicated packaging and bulk routes.
Line 2 is available for the released product.
Fine screens remove rare agglomerates before cement enters bagging equipment. Mesh is clear and reject count remains minimal.
Metal detectors protect packaging machinery from unexpected foreign objects downstream.
Calibration test passed and product mode is restored.
Conditioning air preserves powder flow through every final transfer chute.
Flow is smooth and the air remains dry.
Bag orientation is correct across every magazine.
Automatic bag placers position empty sacks beneath each filling spout.
Rotary packers fill multiple cement bags simultaneously with controlled accuracy. All active spouts are filling evenly.
Electronic scales stop filling when every bag reaches target weight. Target weight reached cleanly on this spout.
Veteran operators verify bag shape, airflow, and stable filling performance. Bag shape is uniform and every valve is seating cleanly.
Filled bags transfer gently onto conveyors without tearing paper layers.
Transfer is centered with no bag damage.
Inline checkweighers automatically reject underfilled or overweight bags before sealing. Test reject activated correctly, production weights remain compliant.
Valve closures secure cement inside bags while allowing clean handling. Closure profile is smooth across the full valve. Bag cleaning systems remove surface dust before labels and codes apply.
Print remains clear and the bag surface is clean.
Printers mark production dates, lot numbers, and traceability details clearly.
Date, shift, and lot number match the order.
Vision cameras confirm every printed code remains readable and complete. Unreadable test code detected and diverted correctly. Brand panels and safety instructions appear consistently across each package.
All panels are aligned and clearly readable.
Seal inspections identify damaged valves, torn paper, or leaking cement.
Seal is secure and no powder leakage is detected.
Specialty small format cement bags are boxed for cleaner retail distribution.
Count confirmed. Close and label this carton.
Layer forming equipment arranges full-size bags into precise, stable pallet patterns. Layer pattern is complete with no edge overhang.
Robotic palletizers place completed bag layers onto reinforced shipping pallets. Layer 1 is centered and placement looks clean.
Interlocking patterns distribute weight evenly and prevent pallet movement during transit.
Orientation is correct, with no edge overhang.
Stretch wrapping stabilizes each pallet while preserving product labels and ventilation. Film tension is stable and labels remain visible. Final pallet inspections confirm count, alignment, wrapping, and traceability information.
Count and wrapping are correct. Release this pallet.
Warehouse scanners assign every released pallet to a controlled storage location.
Route this pallet to aisle 6, rack 14.
Automated conveyors move wrapped pallets safely through organized warehouse lanes. Zone B route is clear and transfer is complete. Humidity monitoring protects paper bags and cement from moisture exposure.
Humidity and leak monitoring both remain normal.
Warehouse teams rotate inventory so older approved lots ship first.
Retrieve the oldest released lot before newer inventory.
Cycle counts confirm stored quantities match digital warehouse inventory records.
Physical count matches the system with no variance.
Shipping coordinators match customer orders with approved palletized cement lots.
Allocate the oldest compliant pallets to Dock 5.
Dock teams inspect trailers before loading protected cement pallets inside.
Floor is dry, clean, and ready for loading. Forklifts load pallets in balanced sequences to maintain trailer stability. Place this pallet in the forward left position. Position 1 complete.
Load restraints secure cement pallets against shifting during highway transportation.
Rear restraint is locked and corner protection is secure.
Electronic shipping records connect each pallet with its destination and customer.
Manifest complete. Record the seal and release the shipment.
Delivery trucks carry protected cement bags from warehouses to distribution centers.
Approaching the distribution exit with the load secure.
Construction suppliers receive traceable cement pallets for local project delivery.
Seal matches and the pallets arrived in good condition.
Cement bags finally reach construction sites ready for dependable structural work.
Keep every pallet covered until the bags are needed.